Hey, and welcome to my talk about how you can speed up your CI and also save the environment. Now, those of you that already know me kind of know that we're probably going to touch monorepos. And monorepos have been around for a while. It's only recently that they somehow got trendy again and cool. So let's have a look. And they're really everywhere. For instance, this is the React GitHub repo where they developed the React framework and they use monorepos. Same for Angular, where you could argue Google is kind of known for their big one gigantic monorepo, so Angular naturally adopts that as well. But it also holds for the Vue repository and also for the Vite repository. So why is that? Well, for those open source projects in particular, they want to create such fine-grained packages, so to publish them individually, such that you can, as an end user, install just what you need. So they don't want to have one big part that they publish to NPM, for instance. But still, having those individual fine-grained packages, one will definitely want to develop them as a whole. So still have that developer experience, that good developer experience as you locally develop feature and implement new features. And the main reason behind that is, for instance, something that's called atomic commits. So meaning I change one thing in one package, and I can immediately see the effect on all the other packages, potential things that don't build anymore, tests that break, or like my playground applications, I can test out various scenarios very, very easily without doing different repository hopping, basically. And this is just one big advantage, so getting that fast feedback loop. There's a ton of other advantages when you want to adopt monorepos. And I'm the co-creator of this webpage called monorepo.tools, where we kind of try to list out different advantages of monorepos in comparison to the traditional like single project repositories, often also called polyrepos, and also what kind of tooling support you need there. And one thing that is always coming up when you talk about monorepos, quite naturally, is speed. And why is that? Well, if we have a single repository with one project, we just need to make sure that we have kind of fast build tools such as Vite to keep our build times low, our CI times low. But obviously, if you have a monorepo and we keep adding projects, our build times on CI will go up naturally, right? Like you just add them up and you will end up with longer build times. And this is obviously not acceptable. So what we really want in a scalable monorepo is have a time that looks like this. So it's mostly constant regardless of how many projects you add. How is that possible? Well, let's dive into this topic. And one aspect obviously is important, which is like this individual build tool should be fast. Now, in our case, we already have Vite maybe set up in our project, so builds are super fast, right? But what is faster than Vite? It's actually not running Vite at all. So what do I mean with that? Well, first of all, you need to have a tool that kind of does some more intelligent task scheduling. So not running things serially, but actually parallelizing as much as it can. The next thing is taking shortcuts. So usually tools such as NX and also Lerna, they build up a graph behind the scenes, analyzing your workspace and understanding the dependencies. And with that understanding, they are able to understand that when one node is changed, what other nodes are affected by that change. And that helps us taking shortcuts. Because we really just need to run, let's say, the build, testing, or linting on the project and nodes that are affected by change. And we can cut out all the rest of it, taking obviously much less time. Another innovative approach that a lot of the tools have now is advanced caching. So really do computation caching. Whenever we run a command, we take into account the source code that goes into that command, environment variables, your local machine environment, and much more. And that we compute a hash code out of that and compare it to a local cache. Now, if we have a match, well, then there's no point to actually run that computation because it has already been run before. So we can really just restore it. That is restoring the log files, the log output that you see in the console, such that the developer sees it still as if it was just executed right now, and also potential build artifacts. So if you have a build command, then you might end up having some dist folder with some JavaScript and CSS files in there. So let's actually have a look of how this works in the Vite repository itself. So this is the Vite GitHub repo, so basically where the Vite package is being developed. And what they use is a PnPM workspace setup. So this is kind of a monorepo setup where you tell PnPM, these are the packages that I want to distribute. And this at the same time allows you to say, for instance, in the plugin React, that you want to locally link certain dependencies. So these wouldn't be pulled down from npm, but rather would be tried to find in one of those two folders locally. Now at the very root package JSON here, you see the main commands that the Vite repo here uses. For instance, there is a build command that allows you to run all the packages build. And so you can run that by running PnPM run build. And this would now go through all the different packages and build them. I'm going to interrupt this here because it takes quite a while. It takes up to 30 seconds. And you see also the build output here is actually quite cluttered because there's a lot of stuff going on here. Now, let me add an X to this repo to show you how we can basically speed up some of the things and also improve some of the developer experience parts. So adding an X is really just PnPM install nx, which is a single package. This is a dev dependency, and we want to install it at the root of the monorepo. And so we have a single package nx here now that is a dependency, a developer dependency for the entire monorepo. What you usually also want to do, while we could just use nx now, you also want to do some slight configuration. And so let me actually just create an nx JSON file, which you can either do by hand or just run nx init. And this would now create a JSON file in here with a couple of options. And this mainly is regarding to the caching. So here, for instance, we can go to the cacheable operations and say to nx, well, I think the build commands and the test commands are probably cacheable. And so what nx here does is really just take the build commands, let's say here, for instance, for the Vite plugin. If we go in here, there should be build scripts, and nx caches this build script. If you think that the build bundle should also be cached, then you can definitely add those as well as the linting and much more. But it really depends on your monorepo setup. So nx is kind of cautious and doesn't specify anything upfront. But what this already allows us is we can actually now run with an nx command all the builds of the packages. For instance, this would be the equivalent one. And so let me just prefix this here such that it takes the local binary. But what you already can see now, it has a much nicer print output. And so this is already some developer experience improvement because we really see what is being built, how long it takes, but we don't see all the necessary details, which is usually not that important, especially if you run a batch of commands. So the build is finished, and the cool thing now is since we have caching enabled, if I rerun the same, it is basically instant. It took a couple of milliseconds to actually spit out everything here. Now, why is this important? Well, you don't need to build always everything, right? So for instance, let's go to this playground. There's a package called Wasm. And this is basically a playground as far as I have understood, where they test out different things, such as Wasm compilation. Now, this here is definitely dependent on Vite because in its build script, it uses Vite to pre-build its things. Now, here, however, there's no dependency specified, which would mean if we run here Wasm without having Vite built before, so let's actually remove that dist folder here, run that Wasm script, it would probably fail because it doesn't find Vite. And so things like that need to be fixed because this is just something that is expected to be in the repository already configured. So let me actually go and fix this, and we can do this very easily by just adding here a dev dependency that points to Vite. And we also want to make sure that this is a local dependency. So if we install now actual PnPM packages again, that Wasm package here should now have an actual node modules folder that points to Vite. Now there's one thing left though now, because what we want to tell nx now is, well, it should define such build chains. So meaning that whenever we run a build, and so we can say that in the target defaults here, whenever a build script is being triggered, it should trigger that build script on all its dependencies as well. And so we can do that like this. And with this now we have defined a relationship among those tasks. And we can also see that now in the graph. For instance, if we run nx graph, we can actually visualize that graph. And so here we see all the possible packages, which is enormous, as you can see. But we really just want to see that test.wasm file here. And we want to focus on this and see all its dependencies. And so here we can now see there's a dependency from test.wasm to Vite. And what this gives us now is that whenever we run the test.wasm build, so we do nx build test.wasm, we don't have to worry about Vite being built because that will happen independently. And so if you look at the log output here, you can see one dependent project task succeeded, which is exactly the Vite build because nx understood that this is basically dependency, so it ran that build first. And the cool part is you can also see it was read from the cache. So we didn't have to wait for those 30 seconds for Vite to be built again first, but it just pulled it out of the cache, just ran the test.wasm, and as a result, it is very fast. You can see out of 2 tasks have been cached, which is the Vite build. Now, if you would run it again, obviously 2 out of 2 would be cached. Now, caching is just one of the potential shortcuts that we mentioned earlier. Running only a subset of the entire workspace monorepo graph is another. So for instance, in here, let me actually commit these changes. And now let's assume we work on a new feature. So let me actually create a new feature branch. And in this feature branch, we are going to have a look and change or improve the React plugin here for Vite. So let's go in here and let's go to index.ts file and do something super stupid and just add here a console log. So we basically made a change, so we can commit this change. And so we would now be ready and push this up on a PR to GitHub. Now, nx has a capability of running so-called affected commands. And you can do that by running nx affected and build or test or whatever you want to do. And we can also actually show what would be affected by just appending the graph here. And so if I now go to the graph visualization, I now see a new button which shows me show affected projects. And so if I click this, you can see that it highlights this plugin React where we actually made the change. And then it also shows all the other plugins that are dependent on this plugin React. So those plugins would need to be retested, relinted, rebuilt, and whatever tasks you need to run on those. So these are the affected nodes. And in fact, if we show all projects, you can see here the tiny piece that basically stands out of this whole set of other projects which would also need to be run. So let's actually go back and actually try this out. So let me run nx affected build. And you would see that it runs Vite, which has already been cached, so it just gets pulled out of that. It builds the React plugin. It builds all the other plugins, and then it is done. But you can see it just ran out of all the possible builds that could be run in this repo. It just runs the necessary ones. And so you can see one even got pulled out of the cache. Took 8 seconds, but you can imagine how much more it would have been taken if you would need to run all the projects in this monorepo. And so things like that, shortcuts like that, can really help speed up things. And also in terms of the command that you need to run, you can see I just run affected build. I don't specify any type of project that I need to run. Quite contrary, if you look, for instance, at the CI setup here in Vite, right now here, the projects are being specified independently. So first the build is run, which prepares the packages, and then a couple of different test projects are being run based on those prepared packages. While you could substitute them now easily with the knowledge that you got, which I've shown in the last couple of minutes, by just using some of those affected commands. We don't have to worry about building first, but we can just run the tests because based on the dependency setup that has been there and based on the knowledge nx has based on the project graph, it would run those builds before whenever they are needed. And if they're not needed, it would just not run them. And so this is really powerful, but so far this cache is just local. So this is basically stored in a node modules folder or wherever you specified it to be located, and will just be an advantage for yourself on the local workstation. But usually we don't work alone, right? So there's, for instance, Kate that works on our team and she has her cache. Then there's Jim, which has his cache as well. And there is the CI machine, which also has a cache. Now, the real benefit comes when you combine those, because then I don't need to run everything because maybe Jim or our CI system has executed that task before. And so in NX, you can connect it to a central point and distribute your local cache and share it with others. And this is done via NX Cloud in particular. So with connecting to NX Cloud is really easy. You just basically run a command and it will then link your workspace and set it up in a way automatically to work with the remote distributed caching. And NX Cloud provides a lot of different benefits amongst just the caching. So it gives a lot of insights into the runs that are being executed, especially if you connect it to something like GitHub. You see directly basically run details. So if you have like 100 tasks being executed, you can easily filter just those that failed and also see stats about your cache time savings. So NX Cloud is really about distributing all the things, but not just the cache actually, also the tasks. And so what you can do is you can actually use one of the NX plugins and automatically set up a CI configuration that dynamically distributes your tasks and parallelizes them across different machines. And this CI script, as you can see, is generated automatically for you. You can either use it as is or just take the pieces out of it and integrate it into your bigger CI setup. And this goes all into an efficient task scheduling. So as we have mentioned initially, this is a serial execution where we just execute per package, which is obviously not ideal. Already we can do much better by just distributing those naively or parallelizing them across different agents. And so you can see we already save some time, but we can also see we have a lot of idle time here, where agent 2 and 3 kind of wait until all those long running builds are finished until we get then the final result. And this is exactly where the whole NX Cloud distributed task execution comes into play. So we can really just use that CI script, which we have seen before, and that script will be taken by a central coordination point, which is NX Cloud, distribute those tasks in a way that is most efficient, taking also dependencies among the builds into account, as we have seen. And so you can see that the parallelization degree is much, much higher. And the cool thing is this is dynamic. So adding another agent just makes things more optimal. So you can really dynamically adjust and like add agents or remove agents depending on your need without touching the actual CI setup. And the part is also important is that this takes dependencies into account. So let's say, for instance, we have an NX affected end-to-end test. So we run an end-to-end test on our projects. So those will be distributed among the agents, but in a way that if they depend, for instance, on the output of the builds, those end-to-end tests would be run later on and only when the builds are ready. And the builds would then instantly replay on those agents because there's the caching that is also distributed. So you can really see the benefits and the time savings you get from that. So one thing you might wonder about is what does the environment has to do with this? Well, it actually turns out that by not really running a lot of the commands, you can save a lot of computation time, which results in saving a lot of electricity because machines don't need to be spin up, which results in lower CO2 emissions. Now, here are some of the stats as of September 15th that we have taken out of NX Cloud. And so the last 7 days, we saved across all the NX Cloud hosted projects 6 years of computation time. In the last 30 days, we saved 24 years. And since the beginning of NX Cloud, we already saved over 214 years. So these are massive savings. And there are a couple of cool web pages where you can translate those into actual CO2 emissions, taking some average machines and CPU times. So I hope this was interesting. My name is Juri Strumpflohner, and I actually currently work as the director of developer experience for Nowall, which is a company that is super passionate about monorepos. We have two of the biggest monorepo tools that are out there, which is NX with over 2.5 million downloads per week, and Lerna, which is something that we recently took over stewardship, which also comes with a whole 1.3 million downloads per week. So a huge community that we try to keep and push forward. Now, one of our missions is really to make monorepos approachable, fast for everyone, but especially maintainable in the long run, which is something that doesn't need to be underestimated. So if this sounds interesting, Definitely join us on our mission, follow us on NX DevTools on Twitter, or join our community Slack. Thanks for watching.